All right, so there's multiple ways to visually show a linear inequality. You can do this on a graph. You can do this on a number line. Two main ideas when it comes to number line. Let's say you have something like x is greater than equals to 5. You first want to find where 5 is. Let's say 0 is here. 5 is going to be right there, yeah? Notice how it's equals to 5. That means there's going to be a closed circle, not an open one. It's going to be closed. If it was x is greater than 5, then that would be an open circle, okay? And greater means you go to the right like this. And that's it. That's how you show it on a number line. It's not that tough. So let's try this one. We'll just try a bunch of these. So for the first one, it says x is greater than equals to 2. So when you're doing this on an assignment or something, just put some numbers in here like this, like whatever, yada yada. And this keeps going infinitely in both directions. Step 1, where's our starting point? It's at 2 and it's equals. You want to open a you want to put a closed circle there because of this equals to sign here, because x is greater than equals to 2. And the fact that it's greater than means you want to go to the right like that, yeah? And that's it for A. How do we do B? When x is less than -1, what's the idea? What is the starting point?
-1.
Yeah, -1. Open circle or closed circle?
Open.
Do we go left or right?
Left.
Yep, that is it. Open circle, go left. Boom, done. What about C? Now C is in between two different things. So our lower bound is -2, and the lower bound is not inclusive. So just put a thing there, an open circle. Our upper bound is +4, but is included. So you want to put an open circle there. And x is between these, so just join them up like
Okay.
that. And that's going to be the answer to C, okay? It's not that bad. Okay, now we're going to go backwards. We're going to flip this. They're going to give us a graph, and we're going to have to come up with what equation it represents. Look at A. What do you think the equation is? It's pretty simple.
X is smaller or equals to 3.
Yeah, that's it. Less than equals to 3. What about B?
It's between 2 and -1.
Yeah. Is one of them inclusive?
-1.
-1 is, right? And there we go. That's just the answer. All right. You think you got this in the bag? No, you don't, because I'm gonna throw a little bit of a curveball, like we do, right? Like we always do. This one's gonna trip you. Can only use one x. I mean, we know this one's x is greater than 2. We know that one's x is less than 2. Now you want to combine these two. It's tricky for sure. I'm gonna have to use a function. Something that we have done. If anyone's able to do this in your class, it's gonna be you. It's tricky for sure. All right, this is how you do this one. Notice this number, -2, right? If you take the absolute value of -2, you get 2. So they're related in terms of the absolute value function, y equals to absolute value of x. This thing here, this thing just gives you the positive number. Like, what's the absolute value of 5? Well, that's just a 5. What's the absolute value of -5? That is also a 5. That always gives you the positive. It kills the negative sign. Graphically, it looks like a parabola, but it's extremely sharp. It's like a V, whereas a parabola is curved, right? So to do this question, it's going to be the absolute value of x, right? Greater than or less than 2. Because if we go this side, we're going to get -3, -4, -5. If we go here, 3, 4, 5, these are the same things as these if you take the absolute value. So absolute value of x is greater than 2. That's going to be the answer to this question. Okay?
Uh-huh.
So remember that absolute value. Okay, same question, but a little bit different. This one, you don't even need an absolute value. This one, you can just say -1x is 1, right?
Mm-hmm.
But you could write this in an absolute value notation because this and these are related. So it's going to be absolute value of x. Is it going to be greater than or less than 1? Well, can it be 2? No, it can't, right? So it must be less than. There we go. This means the same thing as this for this question.
Okay.
Well, the absolute value is necessary when it goes like this, and where you can only use 1x, given that these two numbers are the same. How difficult does this really get? Doesn't really get that difficult. You can speed run this. Speed run just means like do a lot of problems really quickly in a flash. X is greater than 3, put a 3 there, greater than, boom, gone. Less than 4, put a 4 somewhere, we'll go to the left, right? Most of these are extremely easy. Like for f, x is greater than -4. You want to put all the numbers here, like 0, 1, 2. I'm just not going to put them for the sake of time. Boom. That's f. You want to do L, 1 and 3. So this is 1, this is 3, and x is between them. It's inclusive, so a closed circle like that, and you are done, right?
Mm-hmm.
These are all pretty simple. The only ones that are difficult is the absolute value one, which is not here at all. Like again, all these graphs as well. This is between -1 and 3, and it's exclusive because it's open circle. What about H?
It's the same thing, but 3 is inclusive.
That's it, right? That's it. It's the basic idea is very simple here. But then the difficult ones is always gonna be the word problems. But here, I think this one, the word problem, is also pretty simple. All right, it has a minimum speed of 30 and a maximum speed of 70. How do you draw this on a number line?
You make a point at 30 and 70.
Right, is it inclusive or no?
Inclusive.
Yeah, because you can go at 30, you can go at 70. What's the equation for part B? Write an inequality to describe your diagram. Well, you have the graph up there, right? It just says write the equation for this inequality. It's very simple. It is just going to be 30 less than 70 less than. What's our variable?
V.
Right, and you are done. Cool.
Mm-hmm.
Let's see how difficult does this really get. Okay, here we go, linear inequalities. The idea is just the same as linear equations. The only difference is you have to be careful when you're multiplying or dividing by a negative number. How do we solve this inequality?
You add 7.
Right. So you get 6x is less than or equals to 12. And now what?
You divide by 6.
right? So x is less than or equal to 2. If you want to denote this on the number line, start at 2, and then, well, this is 2, and then it's going to be a closed circle, goes left, okay?
What if 6 was negative and then you have to divide it?
Okay, so negative 6x is less than this. You just divide it still, it's going to be negative 2, but whenever you're dividing or multiplying by a negative number, the sign in the middle flips.
Okay.
So the answer to that one would be you start at negative 2 and you go to the right, like that. Okay, cool?
Mm-hmm.
That's the only difference. I guess this kind of also, what do we do here first? There's two things you can do, both of them are right. One of them is better than the other. What would you do?
Open the bracket.
Yeah, that's definitely on the table. What else could you do?
You could divide by 4.
Which one do you think is easier?
Dividing by 4.
Yeah, that'll save you an extra step. So x minus 2 is 5, x is 7. If you open the brackets, you get 4x minus 8 is 20. You gotta add 8 first, right? 28, and then you got, I mean, they're both right, but it'll save you this step in the middle. Easy questions, like we're beyond this. Same idea here. What do we do first? There's only one thing you can do here.
Subtract 5.
Subtract 5. So negative 6x, when you're subtracting, it doesn't change anything. It's only when you're dividing or multiplying by a negative number. So negative 19 minus 5 is negative 24. What's next?
You divide by negative 6.
Yeah,
And then the sign flips.
right. So x is greater than 4, and that's going to be the answer. 4 is somewhere here. Closed circle goes to the right, one and done. Okay, triple inequality. We have seen triples before. Same idea. You want to, in the middle, you want to make sure only x remains. You want to get rid of everything, but when you do something in the middle, you have to do it on all three sides.
So you would subtract 2
Yeah,
on all sides.
yeah. So 32 minus 2 is 30. Negative 10 minus 2 is negative 12. Now what?
Divide by 6.
Yeah, divide by 6. So 30 over 6 is 5. Negative 12 over 6 is negative 2. Number line, start at lower bound negative 2, upper bound 5. They're both inclusive, so close circle, and you are done. Easy as that. Same idea here as well. Okay, this one was not open, whatever. It was the same question. Most of these are gonna be pretty simple. Let's do some easy ones, and then I'm gonna give you something that you may not be able to. Okay, here. What's the first step? What would you do on both sides? Remember, in the middle, we only want an x. We need to get rid of the 4, that 5, and the 2.
Do you subtract 5?
Is that right? That's your final answer? No, you can't. I'll show you why you can't subtract 5. I mean, you can do whatever you want, but by subtracting 5, can you kill this 5 with this minus 5? Do they cancel
No.
out? No, they do not cancel out because this one has a denominator of 2, right? So if you subtract 5, I mean, this is the same thing as if you take the LCD, it's going to become negative 10 over 2. Doesn't help us, okay? What about dividing by 4? Would that kill off the 4 in the numerator?
No.
No, it would not, right? 4x plus 5 over 4. Do not cancel out these 4s. You cannot cancel them out.
So you multiply by 2.
That's the only play here. Multiply all three sides by 2. So in the middle, you're left with 4x plus 5. On the right, 2. On the left, 1. What's next?
Now you subtract 5.
Now you subtract 5. So 2 minus 5, negative 3. 1 minus 5, negative 4. What's the last step?
Divide by 4.
Yeah, so negative 4 over 3. X negative 3 over 4. And that's it for this. Graphically, what does that look like? These are fractions, so it's a little bit weird. So this is that going to be to the left of negative 1 or to the right of negative 1? Negative 4 over 3.
How did you get 3 at the bottom?
Right, that's wrong. It should have been 4. So negative 4 over 4 is negative 1. Negative 3 over 4 is, well, negative 3 over 4. So actually, this is not that bad. So negative 1 is right here. So negative 3 over 4, is it to the right of negative 1 on this number line or to the left?
To the left.
So negative 3 over 4 is here. Is that it?
Yes.
No, it's not, because negative 3 over 4 is like 3/4. It's negative 0.75, right? See, 0 is here. This is negative 0.1.
Oh,
This is going to be negative 0.5. Negative 3 over 4 is going to be somewhere like here. So it's to the right.
okay.
What about negative 1 point, or negative 4 over 3? This is the one that I was trying to do earlier. Negative 4 over 3. Is that to the left of 1 or to the right of 1 on the number line?
It's to the left.
Yeah, it's to the left because that's like 1 and 1/3. Okay, let's do some more problems. You can see this whoever wrote this question is from the UK because we have a bunch of pound signs. It's not gonna change anything. So he runs a barbershop. It costs him $20 per day to cover his expenses, and he charges $4 for every haircut. Explain why his profit is this. How did they get 4x minus 20 for the profit? What is profit?
The money he makes.
Mathematically. So there's three things. There's something called revenue. Okay? Revenue is the money that he makes, total money that he makes. So revenue for him is gonna be, he charges $4, right? For every haircut. So 4x is his revenue, okay? And then there's something called cost. Cost is the money that he has to pay, that he pays, right? Usually this is in the form of like expenses. So what's his expense? He has to pay $20, right? So cost is 20. Profit, P, is always revenue minus cost. That's how they got that. P is gonna be R minus C. Revenue is 4x, cost is 20. Profit is the net money that he makes, or that he keeps. Okay, that goes, all of this goes into his pocket. He hopes to make at least $50 of profit per day, but does not intend to make more than 120. Write down an inequality for this situation. It's gonna be a triple inequality, inclusive. What is it? So his lower bound is 50, right? So his profit is between 50 and 120. And what is profit? Well, profit is 4x minus 20. So there we go. That's just it. How do you solve this for x?
You add 20.
Yeah, super simple. 70 over 4 on this side. On the other side, 140 over 4. Right? And that's it. Easy?
Mm-hmm.
Should be easy. I mean, could be tricky though. I mean, it's always the word problems that are going to be tricky. Okay, so he's traveling from somewhere to somewhere, and the distance he can travel on a full tank is between 200 and 320 miles. If m represents the distance, write an inequality involving m. One-step answer. Any ideas? Nope. It's very simple, right? M is the distance he can travel, and on a full tank, he can either travel 200 or 320, and that's it. One and done. Make sense?
Mm-hmm.
Right. Part B wants this in kilometers, okay? Part B wants this in kilometers. And they've given us an expression for m, which is 5k over 8. All we do in part B is replace this m by 5k over 8 and solve for k. Actually, you don't even have to solve for this because it just says write an inequality, and that's it for part B. Part C says solve for k. How do you solve this for k?
Multiply by 8.
Yeah, multiply by 8, so 1600 on this side, divide that by 5. Same thing on that side, 320 times 8 divided by 5, and that's going to give you the answer to part C. Cool?
Mm-hmm.
Was this difficult? You're stuck here for a bit, but again, it's very simple, right? You can travel, m is the distance he can travel, or he's going to travel between 200 and 320, and that's it. A man finds his bill to be between 50 and 90. Come on, you got this. What's the inequality? 50, 90, C. The answer to part A, basically.
C is greater than or equals to 50.
Nope. I mean, that's not wrong, but it has an upper bound as
No,
well. So start with the lower bound
it's
50.
less than
Yeah.
equals to 90.
So 50 lower bound, C is in the middle, and upper bound 90, and that's it.
Okay.
The bill is made up of a standing charge of 10 pounds. Will this standing charge change? No, it would not. This is your y-intercept. And a cost of 10 pence per kilowatt hour. This is your slope because it's going to change depending on how much electricity you use, right?
Mm-hmm.
That's it. I've given you all the hints. What's the equation for C? This is your y-intercept. This is your slope. And this is your x, basically. Well, the y-intercept is 10. 10 is not going to change, right? This is the same thing as y equals mx plus b or b plus mx, but in this case, it's going to be 10 is your y-intercept plus 10 pence. Yeah, 10n. But pence means it's divided by 100, so 0.1 pounds. Because the units have to be the same. 10 is in pounds,
Mm-hmm.
so that means the pence guy also has to be in pounds. Part C, using your formula, write down an inequality involving n and solve this inequality.
Do you just replace C with?
Yes, that's it. That is it. 0.10n, 90 is the upper bound. How do we solve this for n?
Subtract 10?
Right, so we have 40, 0.10, and then 80. And then you divide it by 10. Dividing by 10 is the same thing as multiplying by, dividing by 0.1 is the same thing as multiplying by 10. There you go, that's the answer.
Okay.
So he can use, or he uses, this person uses 400 to 800 kilowatt hours of electricity, denoted by kWh. That is how we also pay the electricity bill. It is measured in kWh. Okay.
Mm-hmm.
What am I thinking? Power. This is a measure of power. Is also measured in watts. Now we're heading into physics territory, but you can convert watts into kilowatt hours, or the companies do it for us. Let's just briefly talk about it. It's like a light bulb, doesn't use much, especially if it's like an LED bulb. Probably will cost you like $1, maybe not even $1 for like a year. Okay?
Mm-hmm.
Bulb, anything LED is good. It's very cost effective. Okay, let's go off on a tangent here. Why not? There's a bunch of different types of bulbs that you can buy, or like light sources. The most efficient one is relatively new. It's called LED light bulb. This is also has the most cost. It's the highest costing one. Initial cost is high. Or you can have like an old school like fluorescence, or like just a normal light bulb that's not made from LED. It has this thingy in the middle, right? This one actually looks like it's white in color on the from the outside, and
Uh-huh.
it has some like gas inside of it. So if you've ever seen one blow up, right, it's gonna release some gas. It's got white smoke. This one, the normal one, it just straight up blows up. Looks like this, usually yellow in color, I think. It's this one is transparent. It just looks like a glass. Inside of it, you have this like little like heat source. So now the
Mm-hmm.
question is, why is LED good? So now if you think about what exactly is electricity, what it's doing is it's an energy transformation. It's converting heat energy, okay, or even like electrical energy, let's say electrical energy, into light energy. That's what it does, the bulbs, okay?
Uh-huh.
So this guy here does this as well. All bulbs do this. They convert electricity into light. But this guy is inefficient because it releases a lot of its energy into heat. So if you ever touch one of these guys, they're gonna feel very hot, okay? It's
Mm-hmm.
because some of the electrical energy has been transformed into heat energy. These guys also get hot, but nowhere close to that. So it's more efficient in transforming this. So if you have a choice between an LED bulb and a non-LED bulb, always go for the LED bulb. But there is a market for these bulbs still out there. Was there a market for these? Because these ones cost less to start with. Okay.
Mm-hmm.
Uh, so why is LED good? One thing, it's efficient in converting electricity into light. Two, it is designated for way more hours. Like it has a longer lifespan. This guy will die quick. If you use it every day, probably won't even last you like a year. This guy will last you 10 years. So that's the difference. This thing is relatively new. I mean, light as electricity as a whole is relatively new. It's about like what 200 years old, I think, when Nikola Tesla initially, well, he didn't invent electricity, but he invented AC current. So it's relatively new. It's 200 years. This thing is like probably like 50 years. So we're making advancements every day. So that is light in a nutshell. Some places of the world, they have something called power cuts. We don't have it here. But if you go to like some third world countries, they will have power cuts. Now, what are these? It's because their system can only store so much energy at a time, okay? The energy that I can store is like limited, or sometimes it's not even full. So what does this mean for the end consumer? There is a schedule. I guess sometimes it's random, but there is a schedule. It's going to tell you which days, which time you're not going to have power. Like that.
So you know what happens?
You, well, it depends on the country and the city, I guess, but sometimes it just goes off on its own. Like there's no knowing when it's gonna go off. Sometimes, most times, you will know when it's gonna go off. So yeah,
Why
and these
can't they
are,
like fix that?
this is gonna be also during peak hours. They could fix it, but they need money, which they don't have. It's not about fixing, it's about like generating more electricity. It usually happens in like poor countries. Okay. And this power cuts is
Mm-hmm.
gonna happen during peak hours as well, which is very bad. That's why if you go to these countries, they don't have like an electrical stove. They're gonna have a gas stove, which doesn't require electricity. It requires like a gas source, usually like a cylinder. Butane
Mm-hmm.
gas is, I think, the most popular. So these countries, candles, very popular, sells a lot. Like a lamp, like a rechargeable lamp, sells a lot. But again, people are smart, right? So all these houses, what they have is something called like an inverter, it's called, which is just a fancy word for saying battery. So they have something called an inverter, okay, which is a battery that powers, it's like a rechargeable battery for the whole house or the apartment or whatever. So they have this, which powers a lot of the essentials. So it'll power your like router and whatever you want it to power.
I've
Like a,
seen one before.
right, you've seen one. But this guy doesn't do very well. I mean, it's limited. The amount of power it can dissipate is limited. So TV on inverter is a no-go. TV or like a monitor or anything like that is a no-go. Laptops are good. Laptop is a go because they don't use that much electricity to charge.
Uh-huh.
But like a desktop, nope. TV, nope. PlayStation, none of that. None of that. Washing machine, big no-no. You don't want to use a washing machine on an inverter. So there are some things it's good for, some things it's not good for. So yeah. So that's how they make do. But not everyone can afford this. That's why they have these guys, candles and rechargeable things. In fact, there's a whole topic about like battery efficiency. Extremely interesting topic. A lot of people, like chemical engineers, they work in this area. Some of them, not all of them, obviously, but a very popular topic. Because if you can come up with a battery, right, like that's better than what the market has to offer, then yeah, you'll be rich. You can sell it. The thing about battery is that it dies down over time. Like, what do I mean by that? I'm talking about rechargeable batteries. Over time, it dies, right? Like your phone,
Mm-hmm.
maybe the first few months you got it, the battery is good, but like after 2, 3 years, nope, full charge won't even last you half a day. So battery, there's like a diminishing effect. Now, why is there a diminishing thing? We're on this anyways. Let's just briefly talk about this. Because batteries rely on something called current, okay?
Mm-hmm.
Current is something called, it's a flow of charge. And now what is charge? Charge is something called electrons. Have you ever heard of this? Electrons?
Yes.
You've heard of an atom, right? An atom has a proton, a neutron in the middle, and then there's something called an electron in the middle. So current is basically the flow of electrons from one point to the other. So you have something called a cathode, and then you have something called an anode, okay? So electricity is flowing here in a battery, basically, is how it works. This is how a battery operates. So what happens over time is that this guy, the flow slows down. And because this flow slows down, eventually there will be no more flow and the battery is going to be completely dead. But over time, the flow of this, it slows down. It's because the idea is this guy releases the charge, okay, the electron, then it flows to the other side. But then eventually this guy will have nothing left to release. And then, yeah, over time it slows down. Eventually it will completely die. That's why if you go to a store, we're not even talking about rechargeable batteries. We're just talking about the normal Duracell or whatever batteries. If you look at the package, there is going to be an expiry date up here. So even if you have a battery in a packet that you've never used, 10 years later, it is going to be dead. Okay? That's the idea behind batteries. It's a very popular topic, something that I'm kind of interested in. If you're into that, chemistry is the way to go, which you will start doing, I think. I don't know when,
It's our next unit in science.
right? Chemistry. You're probably going to start talking about like protons, electrons, and whatnot, but eventually, like grade 10, 11, you're going to see some things that we talked about today. Let's look at this Fahrenheit and degrees. Fahrenheit is a dumb unit. The temperature is related to this temperatures, Celsius, Fahrenheit. There's something else actually which is never used in real life but used a lot in science. There's another measurement of temperature called the Kelvin scale. How does this work? Well, 0 degrees Celsius is 273 kelvins. Okay. 1 degree is going to be 274. You just add or subtract. Like 10 degrees is going to be 283. 25 degrees room temperature is going to be 298 Kelvin. Have you ever
That's
heard of
such a specific amount though, like the number.
Yeah, 273 it is. That's just because they took 0 as baseline. I'm not sure exactly where this number comes from, but this is a scale that we went with, which leads to another idea of something called absolute zero. What is this? This is a temperature. What's the value of absolute zero in terms of temperature? That is 0 kelvins. See the scale? 0 Kelvin is absolute zero. It has a Celsius measurement of, again, you just subtract 273 from both sides. Minus 273 degrees Celsius is 0 Kelvin. This is called absolute zero. What's so important about this? Like what's going on here? This is the coldest temperature in the universe. Nothing goes below absolute zero.
What do you mean?
This is as
Like
cold
it
as it
just
can get.
can't?
Nope, this is as cold as it can get.
How
Like,
do we know that?
because we know, because we've tried going lower and it just does not go any lower. Because I'll tell you why as well. It's kind of interesting. It's because when you think about temperature, what exactly is temperature, right? Well, temperature comes from heat. Okay. What exactly is heat? Heat is the movement of molecules. Like how the faster they move, the more heat it generates. The technical definition is something called the sum of its kinetic energy. Kinetic energy we talked about last time is the energy in movement, okay? Heat is the sum of its kinetic energy. So what happens at absolute zero is that you see these things, these guys, they stop moving completely. So there is no heat. And this is as cold as it gets. Want to know something even more weirder? We know some bacteria that can survive this temperature. So out
How does
there
it work?
How does what work? How do they survive?
Mm-hmm.
It's because they have adapted to it. They have something in their body, something very specific that keeps them warm even when it's really, really cold outside. Well, at this temperature, they're by alive, I mean this, like they won't be moving. They're practically dead, right? But if you
Mm-hmm.
take them from here, if you leave them there for years, if you take it, bring it to your room, and once they thaw, they're gonna start moving. Same thing with fish, actually. This is gonna sound very stupid. Fish, you can catch them, you can literally freeze them, okay, in your freezer. Literally freeze them. And once they thaw, they're still alive.
That's disgusting.
They are still alive. How cool is that though? Humans, we can't do it. We're
Isn't that like how they find like different organisms in ice?
right, right. So we can't, but for some reason they can. Okay? Which is kind of cool.
Mm-hmm.
Go fishes. Anyways, same kind of idea applies to this bacteria which can survive absolute zero, which is the coldest temperature in the universe. Nothing goes cold. There's a lower bound. Basically, when it comes to temperature, there's lower bound. On the lower bound, you have 0 Kelvin, absolute zero. What do you think the upper bound is for temperature? How hot can it really get? What do you think? How hot is the sun? Just throw a random number. Like sun is definitely like water boils at 100 degrees Celsius, right? So sun is probably a little bit hotter than that. 101, would you agree?
Wouldn't it be more?
Yeah, it would be way more. Probably multiply this by 1,000,000. That's
Uh-huh.
just the sun though. Like, is the sun the hottest thing out there? No, it is
Probably
not.
not.
No, it's not. So,
Is there actually an upper bound?
no, there is not. That's exactly it. There
Is
is no upper bound. This can be anything. There's no upper bound. There's a lower bound. There's no upper bound when it comes to temperature. I'm trying to think. What's the hottest thing out there? The hottest thing that I can think of right now is something called supernova, which is when a star explodes, boom, and dissipates into dust. That's the hottest thing I can think of. And how do we know it's hot? It's because we can see them. If it was cold, we will not be able to see them, but we can detect heat using infrared out in the universe. Okay, forget about hot. What about cold? Where do you think is the coldest region of the universe, which is basically absolute zero? Pluto, very far from the sun.
but it's not the coldest.
No, it's not. So somewhere very, so what you're saying is somewhere very far away from the suns, right? Maybe somewhere here.
Mm-hmm. Like far away from
Yeah,
a
far
lot of
away.
stars.
Yeah, so somewhere far away from the suns. No, it turns out that's wrong. This is gonna sound weird as well. The coldest place in the universe is right here on planet Earth in some lab. Because
What?
absolute zero, it's nearly unattainable, okay? It's a lower bound, right? Doesn't mean the bound will ever go there. In our labs, we can go up until like what was it? To negative 273 degrees, right? Negative 270. We can go up to like negative 272.8 or like 9 degrees Celsius in our labs on planet Earth. So as weird as it is, the coldest place in the universe is right here.
But we can't be sure of that.
Yes, we can, because we can measure the heat. So even this guy that we said, right? That guy that's very far away from the sun is definitely warmer than absolute zero. We can measure this, and it is not absolute zero. It's probably gonna be like negative 250 or maybe even 280. Not 280 is not possible. Maybe like 270. But we have pushed the envelope to getting as close to absolute zero as we can right here. It's a lower bound, right? What's bound? Bound means you can approach it, but you probably will never reach it. Think of it like this. As temperature approaches absolute zero. Doesn't mean temperature will be zero, right? The big distinction here. Kind of like this. Let's talk about bounds anyways in a mathematical context. Like what if I asked you what's 0 over 0? Does it exist?
No.
No, 0 over 0. Don't say it's 0. Okay, it's not 0. 0 over 0 is nothing. It does not exist. But now what if we put in a function here? We're going to plug in this function. Sine of x over x. Sine of 0 is a 0. And when x is 0, that's a 0, right? Let's plug this in. I'm trying to show you the idea of bounds. So this is our function, y equals to sine of x over x. When x is 0, what's going to be our y value? Where our y value is going to be sine of 0 over 0, right? And we know sine of 0 is a 0. So now we get a 0 over 0. Now let's see what the y value is when x is 0. It's undefined, right? Would you agree it's undefined? But sine of 0 over 0, or sine of x over x, if you were to take something called its limit, which is basically like bounds, sine of x over x is 1. You can see to the left of that and to the right of that, right? It's slowly getting very, very, very close to 1. So that's the same thing with the absolute 0. It will not get there, but we can go as close to it as possible. And where do we do that? Right here in a lab. And that's the idea behind that. Cool. And we know it's a lower bound because the molecules stop moving, so they give no more heat. We will probably like instantaneously die at that temperature, even if we're wearing like a lot of clothes. The coldest place on Earth is Antarctica. How cold does it get? I think it's like negative 60-ish degrees Celsius there. I think that's the coldest. Let me just quickly look up the coldest temperature ever recorded. Okay, it's way up more than that. It's negative 90. That's the coldest it has ever been. That's pretty cold, right? But it's nowhere close to absolute zero. Not even close. Not even
Wait,
like
so
one.
there's no upper bound on heat because the molecules can like keep moving?
Yeah, they can move very, very, very,
Like
very fast.
there's no end to it?
There's no end to it. Nope. Unfortunately. There is a lower bound. There is no upper bound. They can move, depending on how excited they get, they can move as much as they want. Okay, there is an upper bound event. There's nothing probably hotter than the Big Bang. You know what the Big Bang is?
I've heard of it.
You've probably heard of the Big Bang Theory. We're not talking about that, which is a pretty. Do you know about that show? Yeah, we're not talking about that. But yeah, Big Bang. Big Bang is the origin, so-called. It's an idea, like it's a theory, origin of the universe. So apparently there was something called a singularity. Okay, this is the only thing out there, and then it collapsed on itself and it exploded and it released everything that we know today as the universe. So right there, the second it exploded, I think this is gonna be the hottest thing there ever was and probably ever will be. Because the amount of energy, I mean, it formed an entire universe, so the amount of energy it has is astronomical. Even that doesn't do it justice. So that was probably the hottest thing ever. Volcanoes get pretty hot as well. Volcanoes are cool, but nowhere close to that, nowhere close to the sun. Now our sun isn't even like a big sun. Our sun is like a tiny sun compared to some other out there. So it's not even that hot. That's what I mean. Like our sun isn't even that hot. Okay. Interesting talks about temperature. Anyways, how do we do this question? We have an inequality given in terms of Fahrenheit. we want one in terms of Celsius. It's basically the thing that we've been doing all day.
You just replace F.
Yeah.
And then you solve for C.
Right, so 60 less than F is 32 plus 9 over 5C, 70. How do we solve for C?
You subtract 32.
Right. Could we multiply both sides by 5? Would that work? Instead of subtracting 32, could we multiply both sides by 5?
We could.
You could? No, you couldn't, because it's not going to cancel out. If you do 32 over 9 over 5C times 5, yeah? This 5 and this 5 cancels out, but then you're giving this an extra weight. So you can't do that. Multiplying by 5 doesn't help you here. You have to subtract 32. That's the only play. You can't divide by 9. You can't multiply by 5. So you get 28 here. You get 38 here. 9 over 5C. What's next?
You divide by 9 over 5.
Yeah. Or you can multiply by 5 now. And then you divide by 9. Which is the same thing as dividing by 9 over 5. And whatever this is on a calculator is going to be your final answer. Cool? Celsius is a pretty cool scale. Because 0 degrees, water freezes. So everything to do with water. At 100 degrees, what happens with water? Boils, right?
It boils.
So it's very like relatable. Fahrenheit, who knows? There's some weird story behind it, I am sure. It's gonna be like if I remember right, it's the temperature when Fahrenheit is 0 or when Fahrenheit is 100, something boils. It's not water. I'm trying really hard to think of this. I think it's lard or like beer or something from the like 1800s. Let me
They
quickly look
really
at
use beer.
yeah, or something. Well, back then beer was more safer than water. No one really drank water actually. How weird is that? They didn't know about boiling water,
Oh.
right? So if you drink the normal well water or something, so okay, yeah, this is 0. It's not lard or beer. 0 Fahrenheit is when water and salt mixes, apparently. Okay. Yeah, it's not the most relatable of scales, that's for sure, right? That's for sure. List all the integers this satisfy. What's an integer? Cannot have a decimal, right? So what do you think the integers are? Between -2 and 3. The answer to part A.
-1, 0, and then 1 and 2.
Wrong. You're missing 1
Oh, and 3.
and 3. Yeah, that's it. This person said, I thought of an integer. Let's call this I or whatever. Or n, let's just call it n. Multiplied it by 3 and subtracted 2. What's the equation? Multiplied it by 3 and subtracted 2.
3x minus 2.
Right. And then it's between 47 and 62, so it's a triple inequality. Add 2 on both sides, so I get 49, divide by 3. Add 2, so 64, divide by 3, and that's your answer. Easy as that. Cool? Before I let you go, I'm going to show you something. Y equals 3x plus 4. Now let's graph y is greater than equals to 3x plus 4. This is something that we're going to do tomorrow, but I just want to show you what's going on here. So let's say 3x plus 4 is there. 1, 2, 3, 1. Let's say this is 3x plus 4, okay? Now this is the graph of y equals 3x plus 4. How does it differ? Now what changes when we have to graph the inequality y is greater than or equals to 3x plus 4? You pick a point. Let's pick this point, right? Is that point greater than or less than 4? If this is 4, is that point greater than or less than 4?
It's greater.
It's greater than 4. So the inequality looks like this. Just draw like arrows on this side. Like that. And that's going to be your inequality. Y is greater than or equal to 4. I want to see how Desmos does it. Y is greater than 3x plus 4. Yeah, like that. They just shade it. And this dotted line means it's not inclusive. If you want it to be inclusive, then it's going to change into a straight solid line. Okay?
Oh, okay.
So we're going to graph inequalities tomorrow. All right, that's it for today.
All right. Thank you.
See ya.